Hi everyone, this is Miss D here. I know I'm not there today, neither is Mr. Mans or Mrs. Eaton. So what this video is going to help you with is the back page of the Unit 6 Day 3 worksheet. So we're going to flip over to the back and we're going to start with numbers 1 through 4. So the directions tell us to use the graph to determine whether each system has no solution, one solution, or infinitely many solutions. So number 1 gives us two lines to look for on the graph. It gives us y equals x minus 1 and y equals negative x plus 1. So first we're going to want to pick out the first line, y equals x minus 1 on the graph. So we can look for that one, and I'm going to highlight it for you. So here is our first line, y equals x minus 1. Now we're going to look for our second line, y equals negative x plus 1. And highlighted here is our second line. So, since these two lines intersect at some point on this graph, we know that the system is going to have one solution. So that's what we're going to write for number 1. Now, looking at number 2, we're given two lines again. We're given x minus y equals negative 4, and we're given y equals x plus 4. So again, what we can do is we can find both of these lines right on the graph as provided. So x minus y equals negative 4 is right here, which I am highlighting for you. And our second line, y equals x plus 4, is the same exact line, but the equation is just rewritten differently. So, because we have the same exact line in both equations, we can write as our answer for number 2 that we have infinitely many solutions. So, for number 3, we can look at the two lines that it gives us here. So it gives us y equals x plus 4, and it gives us 2x minus 2y equals 2. So again, I'm going to highlight both of these for you. So the first equation is y equals x plus 4. So we can find that equation and highlight it. And then the second line is 2x minus 2y equals 3. So now we can find that equation and highlight it. So what we can see is that we have two parallel lines on our graph. And because we have two parallel lines, that means these two lines are never going to intersect. So from that, since they're never going to intersect, we will have no solution, which we will write under number 3. And then number 4, we're again given two lines, y equals 2x minus 3 and 2x minus 2y equals 2. So let's start by finding these two on the graph. So y equals 2x minus 3 is right here, which I'm highlighting. And 2x minus 2y equals 2 is right here. So we can see that these two lines are intersecting at some point. So our answer to number 4 will be one solution, because they will be intersecting at one point. So now we can move on to number 5. So Nick plans to start a home-based business producing and selling gourmet dog treats. He figures it will cost $20 in operating costs per week, plus 50 cents to produce each treat. He plans to sell each treat for $1.50. So I'm underlining those key numbers that we have. So part A says to graph the system of equations y equals 0.5x plus 20 and y equals 1.5x to represent the situation. So to start, we're going to graph the first equation, y equals 0.5x plus 20. And to help us out, we can list our m and we can list our b. So, our m for y equals 0.5x plus 20 is 0.5. and our b is 20. So, as we are starting to draw our equation on the graph, we're going to start with our y-intercept, which is 20. So we will put a dot right on 20. And then we are going to use our slope of 0.5 to help us out. So since 0.5 is kind of a small slope and the graph is going up by 5s on the x and y axes, we can change that a little bit. So we know that 0.5 is the same as 1/2. So we can write 0.5 equals 1/2. And then, since we know our x and our y are going up by 5s, we can change this to 5/10. So if we multiply the numerator and the denominator both by 5, 1 times 5 is 5, and 2 times 5 is 10. So we get 5/10 is also our slope. So now that will help us out in graphing our line. So now we can use that. Starting at 20, we can go up 5 and over 10 and make a point. And then we can just do another one, up 5/10 and make a point. And then we can make a line using that. So my line's not going to be very straight, but it'll be alright. So now we can graph our other line. So again, we can list our slope, which is m equals 1.5. And that's the same thing as 3/2. And then also, we can list our b. So we have no b, so b equals 0 in this case. So b being 0, we can put a point at 0, 0. Then, since our slope is 3/2, we are going to want to figure out, well, what can we change 3/2 into to make it easier for us to graph this line? So down here, 3/2. Again, we can multiply both top and bottom by 5. So if we do that, we get 15/10. So now this is our slope for our second line. So we can go up 15 and over 10. And then we can do that again. Up 15 and over 10. Oops. Yeah. So now we have our 3 points, so we could draw that line to connect them. So then part B is asking, how many treats does Nick need to sell per week to break even? So, what we have to look at, for 2 equations to break even, we need to find that intersecting point on our graph. So we can look, and then our intersecting point is 20, 30. But the question is asking, how many treats does Nick need? And we can check our axes to see, is the 20 or the 30 the number of treats? So as we can see, treats is our x, so the answer is 20 treats. And what we should also do is we should label our 2 lines. So the first line we wrote was y equals 0.5x plus 20, and our second line was y equals 1.5x. So then we have that graphed completely. Moving on to number 6, it tells us 2 planes are in a flight near a local airport. One plane is at an altitude of 500 meters and is ascending at a rate of 500 meters per minute. The second plane is at an altitude of 5,000 meters and is descending at a rate of 500 meters every 2 minutes. So part A is asking us to write a system of equations that represents the progress of each plane. So we're going to start by reading our sentences again. So the first sentence that will help us is that one plane is at an altitude of 500 meters and is ascending at a rate of 500 meters per minute. So we know it's going to be y equals, and since the plane is at an altitude of 500 meters, that is going to be our b. And since the plane is ascending at a rate of 500 meters per minute, the per in that part tells us that this other 500 is our rate, so that's our m. And we know, because the plane is ascending, our rate has to be a positive 500 because it is ascending, so it's going higher. So our rate, or our m, is 500, so y equals 500x, and we saw that our b is also 500, so we have plus 500. Now our other equation is going to be taken from the second sentence. So the second plane is at an altitude of 5,000 meters and is descending at a rate of 500 meters every 2 minutes. So with the first one, we had per minute. So there was technically 500 over 1 for our first equation. Now our second equation says every 2 minutes. So instead, since it says a rate of 500 meters every 2 minutes, that means our slope is going to be 500 over 2. And then the second plane is at an altitude of 5,000 meters and is descending. So since the plane is descending, that's going to make our slope a negative 500 over 2. Because the plane is going lower and lower, so it's going to be a negative value for that. Now it also tells us that the plane is at an altitude of 5,000 meters, so that will be our b. So we're going to put that as our b. So now we have our two equations for part A. Part B asks us to make a graph that represents the progress of each plane. And it tells us to let each block represent 2 minutes on the horizontal axis and each block represent 500 meters on the vertical axis. So we're going to have to label our two axes. So the x-axis goes up by 2 every line. So we're going to write down each of these 18, 20. And then it tells us that the y-axis is going up 500 every time. So we will write down a few of these as well. Okay, so now we need to make a graph that represents the progress of each plane. So we're just going to graph the two equations that we made. So our first graph we're going to make is of our first equation, y equals 500x plus 500. So that plus 500 at the end is telling us that our b is 500. So we're going to put a dot right on our 0, 500. On the y-axis. Then our slope is 500 over 1. So we're going to have to go up 500 and over 1. But since our x-axis is labeled by 2's, it would be a little easier if we change our slope from 500 over 1 to 1,000 over 2. So we can multiply the top and bottom of 500 over 1 by 2 to get 1,000 over 2. That'll make it a lot easier to graph our line. So now we can go up 1,000 over 2. You can do that a few times. So now that we have our first line graph, we are going to want to graph our second line. So we can start with our B, which is 5,000. So we will put a dot right on 5,000 on our y-axis. And then we can look at our slope, which is negative 500 over 2. So again, I'm going to want to change that slope to something that's, actually we don't even have to do that because our slope is negative 500 over 2 and our times are going up by 2. So never mind, we don't have to change our slope. So since it's negative 500 over 2, we are going to go down 500 and over 2. And we're going to make a few of those. And then we can draw our line, but you will be using a straight edge to do that because mine is not perfect. There. So now we have our graph for B. So part C asks us, after how many minutes will the two planes be at the same altitude? So before we do that, we can just label our two lines on our graph. And then we can look at part C, asking us after how many minutes will the two planes be at the same altitude, which the two planes will be at the same altitude when the two lines are intersecting. So we can find that point of intersection, which is 6, 3,500. And so it wants, after how many minutes will the two planes be at the same altitude? That same altitude is our second number, 3,500, because that is what our y's are being represented by. So 6 minutes will be our answer because 6 is our x value, so it'll take 6 minutes for the two planes to be at the same altitude. So now what you guys can do is you can go to the next worksheet that is called What Did the Teacher Do with Ogar's Cheese Report? And you're going to do exactly what we learned to do on Friday, which is graphing the two lines that they give us and finding that intersection point. So do that for each of these problems. You can solve that riddle that they have at the end for you. And you have the rest of the period to work on this, so go for it.